So I want you to think about the last thing you ordered online. It probably showed up at your doorstep in, a matter of days.
Yeah, usually pretty fast.
Right. But before it even got to that delivery truck, it had to pass through this massive, chaotic, and just heavily strained choke point. I mean, an international commercial port.
Oh, absolutely. The sheer volume of global trade right now has just completely outpaced the physical limits of, steel, concrete, and human labor.
Yeah, we're hitting a hard ceiling on how fast you can physically move a steel box from a ship to a truck using these old manual ways.
Exactly. Ports are facing these massive challenges like insufficient hinterland capacity, severe traffic congestion, and security bottlenecks. The legacy systems are just breaking down under the weight of it all.
It's forced the industry into a corner.
Mm,
Which brings us to the mission for today's deep dive. We're looking at this incredibly comprehensive academic study.
right.
It's titled A Comparative Analysis of Smart Port Digital Transformation and Sustainable Development Strategies in International Commercial Ports of Taiwan, Japan, and South Korea.
Quite a mouthful, but
Yeah, super important though. The goal today is to really explore how the Fourth Industrial Revolution is trying to transform these massive maritime hubs.
going from basically analog parking lots to highly intelligent smart ports.
Right, and we're going to see why this hidden digital arms race directly impacts the speed, the cost, and even the environmental footprint of literally everything you buy. Okay, let's unpack this.
Sounds good.
Before we get into the wildly different strategies of South Korea, Japan, and Taiwan, we really need to establish what a smart port actually is, right?
Yeah, we have to look at the baseline technology they're fighting to implement. We're talking about the Leap to Port 4.0.
And that's not just like upgrading the Wi-Fi or buying new software for the terminal.
No, not at all. It's a complete neurological rewiring of the port's ecosystem. It's not just importing tech. It's this comprehensive transformation involving infrastructure, platforms, and policy.
Right.
They're integrating big data, IoT sensors, artificial intelligence, and blockchain to create a synchronized, autonomous network.
Which sounds super sci-fi. But the real cornerstone of all this, the thing that makes Port 4.0 actually work, is this concept of a digital twin.
Yes, the digital twin is huge.
It's fascinating because a lot of people think a digital twin is just, a highly detailed 3D map.
Yeah.
But it's way more than that.
Oh, yeah. It's a localized, real-time virtual replica of the port. It ingests millions of data points per second.
From everywhere. Right?
Exactly. From IoT sensors on cranes, shipping containers, tidal gauges, even truck chassis. It takes all that telemetry and runs these predictive AI simulations.
So it's basically doing ETA forecasting, resource allocation, and scenario simulation all at once.
Yeah, which means port authorities aren't just reacting to bottlenecks anymore, they're actually preventing them before they happen.
Okay, so think of it this way. A traditional port is like a giant, super complex group project where nobody's allowed to talk to each other.
That sounds like a nightmare.
Right. But a smart port, using a digital twin, is like having a shared real-time Google Doc where every truck, crane, and ship knows exactly what the others are doing at all times.
That's a really good way to put it. And the source points to European ports as the early proof of concept for this.
Right, like the Port of Rotterdam.
Exactly. They moved to full automation and saw a 40% increase in productivity while cutting labor costs by 70%.
That's massive. And didn't Hamburg do something similar?
Yeah, the Port of Hamburg in Germany uses a system called D-Via. It feeds real-time traffic data directly to truck drivers.
So they avoid congestion before it even forms at the terminal gates.
What's fascinating here is that smart ports aren't just about speed. They're heavily about environmental sustainability.
Oh, totally.
Like Rotterdam's automation is designed to operate on wind power. They have this zero emissions goal. When an AI stops 1,000 diesel trucks from idling in a line for 3 hours, you are drastically slashing the carbon footprint of global trade.
So that's the gold standard, right? A frictionless, zero-emission, highly profitable ecosystem.
That's the dream.
Now that we know what the gold standard is, let's look at how two massive Asian maritime powers are taking wildly different, just incredibly ambitious approaches to reach it by 2030. Let's start with South Korea.
Yeah, South Korea is playing a very aggressive offensive game, specifically at the Busan port. They want to be a top 3 global port by 2040.
And they're spending serious money to get there. In 2025, they established a dedicated digital AI department.
With a massive budget, we're talking 892.1 billion won by 2030.
That's wild.
And that capital is being used to eradicate operational silos. The study highlights their chain portal logistics platform.
Which uses blockchain, right?
Exactly. Historically, terminal operators and shipping lines fiercely guarded their data. But this blockchain ledger forces them to exchange data organically.
They also have this app called Alcon. It brings that data integration all the way down to the truck drivers on the ground.
And it uses voice-activated conversational AI, which is brilliant.
Right, because a truck driver navigating a crowded port can't be scrolling on a touchscreen. So they just talk to the system to book their arrival time, which prevents port congestion.
But South Korea is also pushing into physical AI. They're developing robots to do the high-risk jobs.
Like mooring ships, which is incredibly dangerous.
Extremely. Handing those massive mooring lines under tension is lethal if one snaps.
So they're using specialized mooring robots and robots for high-altitude cargo securing, aiming for literally 0 personnel casualties.
Yeah, a fully automated, hyper-efficient, safe environment. But then you look at Japan, and they have a totally different focus.
Right. Japan's Logistics 2024 plan at the Tokyo port splits things into cyber and physical ports. But their main thing is disaster resilience.
Which makes sense given their volatile geography. They use this integrated web of low-orbit satellite imagery, GPS, and drones.
So if a massive earthquake hits Tokyo, they can instantly monitor damage to the facilities.
Exactly. The AI detects subsidence in the concrete piers, generates a damage assessment, and dispatches emergency drone fleets to route relief materials.
It's a defensive strategy to ensure the supply chain bends but doesn't break.
Right. It shows how the tech adapts to regional priorities.
I have to jump in here and push back on South Korea's master plan, though.
Oh, how so?
Well, the study talks a lot about their push for autonomous ships, right?
Yeah.
Massive drone vessels with no human crew.
Yeah, reducing a 3,000 TEU ship's crew from 20 down to 4 saves $1 billion.
And the source notes that 96% of maritime accidents are human error. But, and this feels like a huge miscalculation to me, if humans cause the errors, but also fix the emergencies, what happens to navigation safety when these massive drone ships are entering a crowded harbor?
That's a really valid concern.
Like if a blind 300-meter-long drone ship loses its sensors in a storm without a crew to manually take over, isn't that a recipe for disaster?
This raises an important question, and the researchers actually highlight that South Korea is actively investing in tech to manage these exact autonomous vessel risks.
Really?
They're building this 5G ultra-low latency infrastructure and deploying what they call smart lighthouses.
Oh, wait. A smart lighthouse isn't like a spinning lamp on a cliff.
No, it's an edge computing node. It collects hyper-local marine weather data and the telemetry of every other vessel in the harbor.
Oh.
And it uses 5G to beam that route data directly into the incoming autonomous ship's AI in real time.
So if the ship goes blind, the smart lighthouse essentially takes over and guides it in.
Exactly. It's a digital safety net.
That is incredibly elegant. It sounds like a seamless sci-fi future, but implementing this stuff in the real world is incredibly difficult.
Oh, absolutely brutal. Which brings us to the friction of reality. Let's talk about Taiwan's Kaohsiung port.
Yeah, Taiwan represents the very real digital growing pains of all this. They're implementing their Trans-Smart 2.0 plus plan.
And they are doing some great work, especially with green energy at Terminal 6 and 7, and using IoT for real-time marine weather warnings.
But when the researchers surveyed industry experts on digital transformation satisfaction, Taiwan's Kaohsiung port scored a 0.879.
Which lags pretty far behind Busan's perfect score of 1.000.
Right, so the researchers did this fishbone analysis to figure out why Taiwan's progress is slower. And they found 4 main hurdles: government, environment, equipment, and personnel.
Starting with government, the issue is fragmentation. South Korea has a streamlined Ministry of Oceans and Fisheries.
They just drive a unified vision and control the budget.
Right. But Taiwan has a really complex organizational structure, multiple agencies with overlapping jurisdictions.
Which means a lack of standardized incentives. And for the environment factor, there's just a lack of a concrete domestic commercialization policy for Industry 4.0 in shipping.
Then there's equipment. It's just staggeringly expensive to replace legacy infrastructure and buy all this proprietary AI software.
Yeah, it's a huge capital expense.
Yeah.
But the biggest hurdle of all the anchor dragging the whole thing down is personnel.
Yes, the talent gap.
Here's where it gets really interesting. There is this huge paradox at the heart of the smart port revolution. To build a fully automated, robotic port that operates without humans.
You actually need a massive influx of highly specialized human talent to build and run it.
Exactly. You need data scientists who also understand maritime law and physical logistics.
And Taiwan is facing a severe shortage of new personnel trained in advanced digital maritime tech. Plus, their senior staff are retiring.
So they're losing decades of practical knowledge about the port's physical quirks. The technology can't just deploy itself.
No, it can't. And this is compounded by Kaohsiung's reliance on leased terminals.
Right, which creates this massive bottleneck.
Yeah, think about the game theory here. If you're a private company leasing a terminal, upgrading to a fully automated system costs a fortune.
You have to buy AI software, biometric sensors, optical cameras.
Exactly. So if the Port Authority doesn't subsidize that upgrade, the private leaseholders won't spend the money.
They'll just stick to their traditional manual gate checks to maximize short-term profit.
Even though that creates a traffic jam that hurts the entire port ecosystem.
It just shows that having the tech is only half the battle. If the governance and the talent aren't there, the digital twin is just a nice theory.
Spot on.
So we've seen the successes and the struggles. If you're keeping score, what actually makes a port win this digital race? And how does that impact you, the listener?
Well, the study surveyed industry experts to rank the absolute most critical evaluation factors for smart port success. They agreed on 5 foundational pillars.
Let's break those down. What's number one?
Number 1, ship monitoring systems. Basically using predictive AI to map optimal trajectories for ships long before they arrive.
Number 2 is AI-powered, fully automated container terminals.
Right. Ghost terminals that operate perfectly in the dark without human shift, changes slowing things down.
Number 3, automated gate systems. This reduces manual errors and slashes truck wait times.
This one is huge.
Think of it this way. An automated gate system is like a high-speed internet connection. You can have the smartest AI cranes inside the terminal, but if your entry gate relies on a human exchanging paper documents with a truck driver, which takes, like, 5 minutes per truck.
It's like hooking up a supercomputer to a dial-up modem.
Exactly. If you don't fix the gate, the AI inside is just starved for cargo.
Exactly. Number 4 is the timely provision of navigation and berthing info. Using IoT to give ships hyper-accurate data on tides and berth availability so they never waste fuel idling.
And pillar number 5 is port access management systems. Absolute cybersecurity and physical tracking of every asset.
So those are the top 5.
So what does this all mean? Why should you care if these ports hit these 5 pillars? It's because these 5 pillars are the reason your global goods will soon arrive faster, cheaper, and with a significantly lower carbon footprint.
It's the invisible backbone of modern consumer life.
When they fix the bottlenecks, the massive overhead of delays is slashed. The price of everything you buy goes down.
If we connect this to the bigger picture, the future of logistics is a world where physical cargo is entirely guided by invisible digital threads.
Yeah, we've covered a lot today. We went from the basics of Port 4.0 to South Korea's aggressive AI ambitions, to Japan disaster-proofing their cyberports, to the very real human hurdles facing Taiwan.
It's a digital arms race, and it is only accelerating.
It really is. Which brings us to a final thought I want to leave you with, something straight from the source material that really stuck with me.
Oh, what's that?
The upcoming era of autonomous ships.
Right, the drone ships.
Yeah.
Yeah.
I want you to just ponder how the industry is going to handle the moment a massive, unmanned, entirely AI-driven cargo ship arrives at an entirely automated robotic port.
It's going to be wild.
How will the shore-based human workers communicate with the AI on board to safely dock a massive vessel without a single human on the ship? The legal, technical, and human implications of 2 AIs negotiating the physical docking of 300,000 tons of steel? That is the next great frontier. So the next time a package lands on your doorstep, just remember the hidden digital arms race that got it there.